In this question, we're asked to determine the relative average speeds of some different molecules, with 1 being the slowest average speed and 4, because there's 4 examples, being the fastest average speed. In the previous example linked to this playlist, all of the gases were neon, so they all had the same molar mass. But in this case, we have different gases. We have xenon, neon, and helium. So molar mass is another factor that affects average speed or average kinetic energy. Note that the number of moles of the gas and the pressure of the gas have no effect, so we can ignore those, but we do need to consider the size. So at the same temperature, larger molecules are moving slower. Smaller molecules are moving on average faster. So if we see here, the first thing we notice is that we have 3 of the temperatures are 15 degrees C, and 1 of the temperatures is -5 degrees C. And we also notice that at -5 it's xenon. So if we consider xenon at -5 to xenon at 15, xenon at a lower temperature will be moving slower, which makes this number 1. It's also the largest gas in the sample. Now, the other 3 samples are all at 15 degrees Celsius. So we have xenon, neon, and helium. Smaller molecules move faster. Xenon, which is lower on the periodic table, is much more massive, so it's number 2 at 15 degrees C, followed by neon, which is lower than helium on the periodic table and more massive, so it's 3, and then helium is number 4, which is moving the fastest.